Hello, so this video is going to introduce you to calculating distance on a image in Earth Engine. It's a little complicated, so we'll do our best, and then we're going to talk about this again on Thursday. But to get started with the task, I'm going to go grab the snippet code and come in here and paste it in. And so what we want to be able to do is measure the distance um, from the non-open habitat, which is now 1, into the open habitat. And so to do that, we're gonna try it like this. So I've given you the CRS here, the EPSG 32145, that we're going to use in this, but I gave it to you there as a placeholder. Don't worry about it right this moment. So what we're going to do is go into image, and we're going to use the distance method to calculate distance, which seems straightforward. It takes a kernel, and this thing's skip masked, but let's kind of get there. So grassland distance is where we're going to put the output, and so that's going to be equal to this input, in that we want to measure the distance from the inverted binary. So that's our input layer. And then we're going to say dot distance, because that's the method that we're going to use. And then we need to basically start feeding distance um, with this kernel. So I'm just going to put it on this separate line, but right, it's after a kernel. So if we go to kernel, we're going to look for this Euclidean distance kernel. So a kernel is just this little moving window that we're going to kind of pass over the image. And within that little moving window, it's going to figure out the straight line distance, or the kind of Euclidean distance, using Pythag and all that, to figure out how far away each non-zero cell, how far away each 0 pixel is to the nearest non-zero pixel, like we talked about. And we have to tell it the radius, how big of a window do we want it to work with as it moves across the image, and the units. And notice that it says if the kernel is specified in meters, it will resize when the zoom level is changed. And this is one of the kind of the funky things about working with a web map, where you have images that are stored at different zoom levels, so that when you zoom so depending on your zoom level, you're working with a different image that has um, where the scale changes and the size of the pixel changes, right? At zoom level 13, it's 19, and as I zoom in, it's 4. And this is something that's going to affect the appearance of the zoom level, but we're going to of the distance function. But we're going to talk about ways to make this right as we go through the tutorial. But again, don't worry if this is all a little weird. Just kind of go along with it for right now, and see how we do by the end. So what I want to feed it here is EE kernel Euclidean. And if it's late and you don't want to spell that out, let's just go in here and copy this, because sometimes that can be, look, I'm not off to a good start there. So okay, that's better. And now we need to feed it these arguments of radius and units. And I'm going to use this kind of approach of using a dictionary to hold my arguments, because then that's going to allow me to kind of define what these numbers are actually doing. So radius, I'm going to say 250. So I'm going to something, and then my units, which, right, is not for the cross, but for the Euclidean. It's radius and units are the two things I want to focus on. So radius, I've spelled that right, units, and I'm going to say colon, and this is going to be quotes, a string, meters. So I'm saying, like, let's create a 250 meter kernel, meaning like moving window, and within that, calculate the Euclidean distance for each cell in the raster. Is that okay? Let's go with that, at least for now, and then we'll see how it gets a little funky. So we're going to use this Inferno, which is a nice palette. I've reversed it, but we'll look at it in a second. I like it for distance. And then I'm going to display this thing. I'm going to go for my viz parameters. My minimum is going to be 0, and then my maximum is going to be, let's just say, the size of the window. And then this is going to be my grassland distance. And I could probably have a better title for the layer, but I'm just going to live with that. And I'm going to say false, and then click run, and I'll save it as it runs. It looks like it's going through. That was orange rather than red. And then let's see, if we had this and we're trying to measure the distance of it, we asked for that, and it didn't grab up because I forgot to say the palette. So I'm going to say palette is equal to Inferno. And now I'm going to hit run. Is that right? Because I'm saying for colors, please use this list of colors. And then if I say grassland distance, and there it is. So let's just start by going over to Chipman Hill and seeing if this makes sense, because Chipman Hill is pretty forested. And so what you should see here is that when it's white, if I grab the inspector and I click on this, the distance should be 0. Is that fair? So all of this yellow is going to be 0 because it's the distance from white to it's basically just going to be calculating distance within the black, and the distance in the black is going to be the distance to the nearest white. Is that fair? Because these are zeros and these are ones. Okay, and then that kind of makes sense. If I clicked on the middle of this little tiny block, you should see that it is a kind of a color not far from yellow, and it's just 23 meters. Is that okay? Whereas if I went over here to this, where I have some black here, and I clicked on the middle of it, it's should show you that I'm now towards the center of this large clearing, and the result is I'm almost 250 meters away, because the maximum, this palette goes from yellow to black through this kind of orange and magenta. And since if it's black, it's going to be 250, close to 250, or greater. Is that fair? So then what you should see, the kind of what's a little bit weird about working with Earth Engine, because of this pyramid of zoom levels with images that have different pixel resolutions when you're in the code editor, is that there are going to be parts, like over here, that when you zoom in, there's going to be, first of all, there's going to be holes in the data when you look at it from far away. And as you zoom in, you're going to notice that these things change. And the display of distance seems to kind of change as you zoom in. That's part of just the, again, pyramid of images that we have when we work with the code editor. And what you'll see is at there's going to be a couple of strategies to get around this towards the end of the tutorial. But right now, just know that as you zoom in and out, there's going to be a little kind of strange magic that's going to make you not quite trust this, but we'll kind of take it for now. So the first thing I want to do is to show you a trick on how to get these masked areas. So sorry, if you grab the inspector and click on one of the holes in the data set, I think it's going to tell you that the data are masked. And the idea here is that if you clicked around this, if you clicked a black pixel close to a gap, you should see that it's either at 250 or slightly above. And what this is kind of hinting to you is that these masked areas are basically outside of the kernel that we used. So they are further away from the edge than the size of this moving window that we use to calculate distance. Now, if you remember, if you go back, we were just interested in defining the core grassland that's 50 meters or more from the edge. So it's okay that we don't know beyond 250, beyond we don't know exact distance, because we're gonna threshold this and cut this all, simplify this later on. So right now what I'm gonna kind of do it's a little bit, you might think of it as a little bit of a cheat, but I'm just going to say unmask, and that is a method of images that basically, let's look at it, and that's going to say that if data are masked, when you unmask it, just replace whatever was masked with this value. So if I say unmask 250 and hit run, what you should now see is that if we look at our grassland distance and we go down to some of these larger grasslands that have interiors that were beyond our kernel, that they now appear black. They'll still change as you zoom in, but you no longer have holes in the data set. Is that fair? So I'm going to do a couple more things. If you go over here for step 8, you'll see that the image is called inverted open habitat binary again. So I'm just going to rename that so that we can keep track of it should we use the inspector. This is actually our grassland distance. And I'm going to put that, remember, in quotes so that it's a string, and hit run. And now when it runs, and if I grab the inspector and I have the grassland distance layer that I'm looking at, um, and if I click on it, it's going to now tell me the grassland distance, and it's just going to help me keep track that the grassland distance band, that value is 50. Okay, so then the next thing, the last thing I want to say is that to right now, we're it's a little bit mysterious how it's calculating distance. And we know that it's using this Euclidean kernel, which maybe you're still a little confused about, but I'll show you what a kernel kind of looks like when in lecture on Thursday. Um, but we don't really know what projection it's calculating distance, and we've seen, right, that um, we've seen that the Mercator um, distorts, the lines of longitude that converge on the pole get splayed out, and so that's why you have some of this distortion in the north that we looked at in one of the early labs. So what I would like to do, I'm just going to click run so it gets back to this area, is make sure that this distance calculation is occurring in our Vermont projection. And so to do that, I'm going to type in dot reproject, because that's going to reproject the image so that it runs in, and I'm just going to first do a couple things. One, going to go to here, reproject, force an image to be computed in a given projection and resolution. So I'm just going to force it to be in CRS. So I'm just going to type in, and I'm going to be safe here and put it in a dictionary and say CRS. The coordinate reference system that I would like you to use when you're calculating distance is going to be this CRS, meaning EPSG 32145. Is that okay? So, and you might wonder, well, don't you want to do that before distance, like reproject it and then calculate distance? And Earth Engine's a little bit funny. In order to force this to be in a certain projection, you have the reproject statement follow the method that you want to force into the coordinate reference system. Just get comfortable with this pattern for now. If I hit run, what might happen is and I say get comfortable, I just mean like kind of accept it, or just go with it for right now, if you will. We'll talk more about it. Don't stress out if this seems a little strange, because here's the next thing I'm going to tell you. When you force it to run in this coordinate system, Earth Engine really slows down when you're just trying to visualize data in the code editor. So here's my last kind of strange advice is remember to put in this statement of dot reproject CRS, but then comment it out so that it's not running right now. Hit run, you'll get things like grassland distance to come in a little bit faster. It'll allow you to get through the workflow, and then at the end, I'm going to show you how to basically run this analysis to make sure that you're doing your spatial analysis correctly without introducing projection errors. Okay, so I'm asking you to kind of type out that dot reproject like this, but then comment it out so that it's not going to run as we write and kind of visually inspect our workflow in the code editor, because this is just essentially a drafting platform we write at the very end when we export this workflow to an asset, and that's just coming up down the line. Okay, so I hope that wasn't, I hope your head doesn't hurt too much. Take a break if you want. And I'm going to push on a little bit further, but that is the intro to kind of working with distance in Earth Engine. I'm going to save, try to keep moving here.